All right, hey everybody. Sorry I can't be in class today or tomorrow, but I hope this video helps. If you don't need it, that's fine too, but I just thought I would go through it just in case. And for the first one here, just a gentle reminder that x-intercepts hide in the numerator. So I'm going to highlight this here. So for the x-intercept for this one, if you set x plus 3 equal to 0, you would get -3. And I'm going to put e for even. That means it's a bounce because of the multiplicity of 2 here. So that's going to be a bounce. Okay. The y-intercept, we did not talk about that yesterday, but we know any y-intercept has to be 0 comma something. And so if we evaluate the function at 0, we get 0 plus 3 squared over, and then everywhere we see x, we're going to put in 0. So 0 plus 3 is 3, 3 squared is 9. -1 times -6 would be 6, so divide by 3, and we get 3/2. Okay. For the vertical asymptotes, that's where you set the denominator equal to 0. Okay. So we're going to be looking at x minus 1 times x minus 6. Okay. So if I set each of those equal to 0, we get x equals 1 and x equals 6. And then for the horizontal asymptote, we have to determine if we're bottom heavy or balanced. So if you look, let me rewrite the original here. So f of x equals x plus 3 squared. And if you were to expand that out, you would get x squared, and then x times x would be x squared. So this is actually balanced, and when it's balanced, you take the ratio of the leading coefficients, so 1 over 1 would just be 1. All right, now here's a blank graph with some key features here, and we have to graph the function. So you can start at the far left or the far right, and the question is, does the graph start like this? Whoops. Does it look like this, or does it look something like that? And because we have two x-intercepts here, I know it's going to have to start above, and it's going to hit, E is for even, that means it's a bounce. And then it's going to cross through here. Now this vertical asymptote is not marked even, which means it must be odd. So if one end points to infinity here, the other end has to point to -infinity. It crosses the y-axis there. This is an even x-intercept, it bounces. And because this vertical asymptote is even, if this end points towards -infinity, then on the other side it also has to point to -infinity. And again, I'm moving kind of fast, but you can always rewind if you need to, or replay. Okay. Number 3 is very similar, so you can try that one. Okay. All right, so let's go to example 4. So again, the x-intercepts, they're kind of already given to you. So -3, 0 comes from here. And then x minus 3 would go to 3, 0. So what we're going to do is, to the best of our abilities, we're going to put, change the color. Let's put -3 here and 3 here. Okay. Okay. There's an additional point, 0, 9/16, so that's going to be just a little bit. 9/16 a fraction, it's pretty small. Okay. So let me zoom in here. So let's call it 0, 9/16. And the vertical asymptotes, those can be found by looking at the denominator. So x minus 4 means there's a vertical asymptote at x equals positive 4. And x plus 4 means the vertical asymptote's at negative 4. So I'm going to do a dashed line for that. And then x equals 4. And notice that this is balanced because if we multiply x times x, we get x squared. And down here, if we multiply x times x, we get x squared. So there's an invisible 1 over 1. So that's why the horizontal asymptote is given at y equals 1. All right, so the hard part now that we have the key features is how do we graph? So we can start at the far left or the far right. And for this one, I guess I'll just start at the left. We'll go left to right. So I guess there are two choices. It can either look something like this or something like this. But it can't be this bottom one because that would mean there's an extra x-intercept, which there isn't in this case. So I'm going to erase the bottom one and leave the top one here. So that asymptote keeps going and going and going and going. Okay. Now, x equals negative 4 is an odd vertical asymptote. So if one end points to infinity, the other end has to point to negative infinity. And it has to cross through here. It's an odd x-intercept. And maybe let me redraw this here. Let's just do the horizontal asymptote just at the ends there. There we go. Okay. And x equals 4 is an odd vertical asymptote, which means if this end points to negative infinity, then this has to point to positive, and there's no more x-intercepts there. Okay. All right, so for this one, the x-intercept is hiding in the numerator. So the opposite of plus 1 would be negative 1. Now for an additional point, I like the y-intercept. So to get the y-intercept, again, we're going to sub in 0. So I think that would be negative 1/12. Yeah, negative 4 times 3. So it's going to be just below here. Okay. For the vertical asymptotes, there are two. Okay. So at x minus 4, that means x is going to be equal to positive 4, opposite of minus 4. So that's going to be right here. Oops. And then the other vertical asymptote is x plus 3. So that means at negative 3. And then to determine the, let me write the asymptotes. So we got x equals negative 3 and x equals 4. Okay. Now the horizontal asymptote, we need to determine if it's balanced or bottom heavy. So this is x plus 1, and then if I multiply the first terms in the denominator, it's x squared, plus some other garbage we don't care about. And because the 2 is bigger than the 1, this is bottom heavy. Bottom heavy means that the horizontal asymptote is at y equals 0. All right, so it's time to graph. I think the last time I started at the far left, so maybe this time I'll start at the far right. And the hard part is knowing, like, okay, does it go like this, or does it go like this? And to be honest with you, there's really no way to tell. So maybe let's not start there, but let's maybe go to the middle. Right. So I see we have an x-intercept here. So what I know for sure is that it's an odd x-intercept. It's going to cross. Okay. And because both vertical asymptotes are odd, I know they're going to point in opposite directions here. And that's what the graph would look like. The end behavior, as x goes to negative infinity, the y values get closer and closer to the asymptote, which is just 0. And as x goes to positive infinity, the y values again get closer and closer to 0. For the domain, we go left to right, so it's negative infinity to negative 3. That's our first vertical asymptote. Then negative 3 to 4. And then 4 to infinity. So you can try example 6, and I'll post the key on Canvas. And hope you have a good rest of your day. Talk to you later. Bye.